Hey, it's Leon. And today, what I'd like to do is share a studio recording of a talk that I give at a number of conferences that's called Alert. Actually, you know what? I'll give you the title during the talk. Just sit back and enjoy. A few years ago, I was tweaking a new alert I was setting up, and I accidentally cut 772 tickets twice in 15 minutes. And I think the worst part was I didn't even know I had done it until the entire help desk staff came up and invited me down to their area to close the 1,544 tickets manually. Yes, there was a mass close out function. They wouldn't let me use it. In any case, with the benefit of time, experience, some therapy, maybe a little alcohol, I can reflect a little bit more objectively on this formative event in my career and wonder, really, who was at fault? I mean, was it the tool that let me do this in the first place? Certainly, I had some responsibility in it. I think there's enough blame to go around. But more importantly, I think it was an immature philosophy about what alerts really are. So I'd like to welcome you to my talk today, which is called Alerts Don't Suck, Your Alerts Suck. As I said, my name is Leon Adato. I'm a middle-aged white dude giving a conference talk, and this picture is clearly intended to inspire confidence that I know what the hell I'm talking about. Everything else on the slide is not important. You can look at it. There'll be a link to the slides in the show notes. More importantly, you should understand that this is an oyster talk. Now, what I mean by that is I have 20, 30 minutes to give you this information. I cannot teach anyone anything in 20 or 30 minutes. In fact, in that amount of time, about the only thing I can do is irritate you. Now, when an oyster gets irritated, it does one of two things. It either creates a beautiful pearl or it dies. Now, I sincerely hope I do not irritate you to death today, but I do want you to be forewarned. Instead, what I hope is that I give you just the grain of an idea, which you will then layer over with your own ideas and experiences until what you have is something that is polished and unique and valuable to you. So the SRE handbook defines alerts as, and I'm reading off the screen, a notification intended to be read by a human that is pushed to a system such as a bug or ticket queue, an email alias, or a pager. Now, not to blaspheme the Holy Scripture, but what the FSCK am I supposed to do with that? How am I supposed to feel that alerts are anything except useless and pointless? And that's because the SRE handbook has failed to explain the value of an alert. And ultimately, that's what this talk is about: how to make alerts valuable. Now, if you remember nothing else from this talk, I want to give you the two key ideas right up front. The first one is that, like opinions, email rules are like assholes. Everyone has one and they all stink. Now, what I mean by that is that if you have an email rule to handle incoming alert messages and put them in a folder or something, you've already admitted defeat. You have absolutely no intention to deal with that alert right now. And for an alert, the only valid time frame is right now. That's my first thought. The second one: please enjoy the vista of this beautiful hill on which I am willing to die. And that hill is called FYI alerts are trash. Really, I don't understand why people have these. And a lot of people do. And usually I hear something like, well, when I get the first alert, I don't do anything. But after I get it like 4 or 5 times in the first 20 minutes, then I do. How about this, buddy? How about I give you one alert when that thing has happened 4 or 5 times in the last 15 minutes? Because I do not get paid by the bushel for this. Okay. Again, the point of this talk is that alerts need to have value, and I'm going to share why and how over the next 5 lessons or so. And the first lesson is on the fundamental nature of alerts. The first thing I'd like you to know is that alerts are not the same thing as monitoring. They are different. And the second thing you need to remember is that alerts are not the same thing as monitoring. And the third rule is, for God's sake, alerts and monitoring are not the same thing. Alerts, monitoring, is nothing more and nothing less than the ongoing regular collection of data and metrics and telemetry from a set of systems. Everything else, alerts and dashboards and reports and the rest, are happy byproducts of monitoring, but you have to do the first part to get all the other stuff. By all means, collect all the data you want, monitor the crap out of your stuff, but alerts should always be biased toward action. Here's an example. Every year your boss gets back from All Things Open, or This Is Dev, or DevOps Days, or whatever, with a new pair of socks and a shiny new monitoring tool. And the first thing you're going to do is unwrap that sucker, the monitoring tool, not the socks, and create a high CPU alert. Now, I have a secret for you. CPU alerts are bullshit. High CPU isn't a problem. It was never a problem. If I have an application and a system that is consistently running at 98% CPU, but is processing all the jobs and doing everything it needs to do, you know what I call that? Correctly sized. Okay, now at this point, some of you are thinking, oh, he's going to oversimplify everything back down to CPU, RAM, disk, and bandwidth, and ignore the lived reality of everyone who's watching this, which is dealing with a metric ass ton of metrics, events, logs, and traces on a daily basis. Because what Leon is talking about is that old monitoring stuff, not the new fancy observability that we do. I see this happen a lot. Conversations about alerts getting stuck on the point of monitoring versus observability. And this is an inherently false argument. It was never monitoring versus observability. It's monitoring and observability. It's both. So let me take a minute and flesh out some important nuances about monitoring and observability. Now I'm about to draw a line on the slide. There it is. And I do so with the utmost respect and gratitude to everyone who fought in the observability flame wars in social media over the last few years. And so I need to specify that what I'm about to talk about is for the purpose of alerting only. I am not making any grand assumptions about what alerting and monitoring are writ large across the infosec space or whatever. Also, for those of you who have your observability bingo card, you're welcome. Here we go. First of all, I'm going to talk about monitoring. Monitoring deals with the known unknowns. That means we know something could break, whatever it is. We know what that thing is. We just don't know when it's going to break. And so we're watching for it. The second thing is all cardinalities are welcome. I don't care if something happens all the time or if it happens once in a blue moon or if it's a so-called black swan. Don't care. Monitoring wants all of them. Third, correlation, meaning non-simplistic triggers. It's not just this thing happened, but it's this thing, and oh, by the way, a little bit of that, and it's all within this time frame. That kind of stuff is mostly a manual operation in most monitoring tools even today. And finally, it's domain-specific signals. What I mean is that the things that I'm collecting from a storage system and the way that I determine that a storage system is unhappy or having a problem are fundamentally different than the things I collect and the way I know the health of an application or a network. They are different domains, and therefore the metrics and the elements and the triggers are not the same. Okay. Over on the observability side of that line that I drew, first of all, observability tends to be more focused on the unknown unknowns. We do not know what might break, and we do not know when it could break. Also, and related to that is high cardinality, meaning I'm mostly focused on the unique events, both the unique as far as that one single signal, but also unique is that, hey, I haven't seen this combination of things in a while or ever or whatever. Also, correlation tends to be baked in because it's dealing with a lot of data all the time. And it simply needs to have those correlation rules of, oh, this and this and this and this are relatively unique in this time frame. And finally, observability solutions tend to look at golden signals. Those are metrics and signals and triggers that have a universal application. The golden signals most people settle on are latency, traffic, errors, and saturation. And you can take those and you can apply them to storage or network or an application in mostly the same way in almost every case. So those are the nuances when it comes to observability and monitoring and alerting. Now, I want to focus more to the point on observability and these high cardinality events, which are derived from an incredibly large set of very disparate data types. So you've got, again, a metric ass ton of data coming in. It's all different. It's being normalized, but there's no way a human brain can reason about that volume of data. The only way to get there is to let the computers do the work. Now, marketing folks will tell you that that's AI, except that we all understand that that's a bullshit term for 3 if statements in a trench coat. Okay, sarcasm aside, you can see how it's challenging to talk about alerts in the context of observability. It's just so big. So I'm not saying that all of my thoughts about alerts and all my examples don't apply to observability systems and solutions. They do. It's just challenging to give detailed examples without keeping you here through the end of your day or happy hour or tomorrow or whatever it is. So that's why a lot of my examples in this talk tend to use relatively simple and relatively old school examples. Okay, back on track. Alerts have to matter. Now, of course, they matter to you. You're building them. But more importantly, they have to matter to whoever is actually going to receive them. And that might not be you. It could be you, but it's probably not. Now, what do I mean when I say the alert has to matter? Well, I actually have a pretty simple algorithm for this. It's if and only if, must all be true. You want, the point of an alert is to get someone to do something about a problem that is happening right now. If all those things are not true, if any one of those conditions aren't true, what we're talking about isn't an alert. Now, of course, the next thing you're going to ask is, well, if it's not an alert, what is it? So let's go over that. First of all, if what you have doesn't involve a human, it's a problem that's happening right now, but it's not a human, at that point, you're talking about automation. Let the computer do the work. I'll actually talk more about this in a minute. Second of all, if it's not going to be dealt with right now, but a human does need to know about it and it is a problem, you're talking about a report. And finally, if it's not a problem, but it is something that a human has to know and it is happening right now, you probably are talking about a dashboard. Oh, I said last of all, there's one more. The last one is, if you're not going to do something about it, throw it away. Really, if no one's ever going to do anything about it, what the hell are you doing? Get rid of it. Again, you're not being paid by the bushel. So there are a few common pitfalls when it comes to making alerts that matter. And the first thing is the trigger condition itself. So let's go back to that CPU alert. As I said, CPU by itself isn't a problem. Now, if you have high CPU and you have more jobs in the processor queue than you have CPUs or cores or whatever that are to handle those jobs, and if the situation has lasted for longer than, I don't know, 5 minutes, 10 minutes, whatever your personal trigger is, and also things aren't happening or people are abandoning their shopping cart and all of that stuff. If that is happening, that's a problem. But what I just defined is incredibly different than, oh, the CPU is high, here we go. Also, it's much more actionable. You know what you need to do, whether it is elastically scaling up your system or looking back at the code to make sure you can handle more users or whatever it is. But you know you can do something about it, as opposed to high CPU, which is too vague. Now, sometimes the issue isn't the trigger, but the time frame. Everyone looks at this graph, which is actually from Leon Fayer, so full credit to him. Everyone looks at this and thinks they know exactly where the problem is, right? It's right there. Look, that jump, 4,000, except that might not be it. It could be perfectly normal. That could be it's month end and the accounting department is going to town doing month end closing. Right? Or it could be that this is actually a cloud-based instance. You see that it's not running particularly heavy over there. So Elastic Compute just scaled it down. So relative to the number of systems I have, the CPU or whatever it is operating higher, but it's really just using my resources more appropriately. But what everyone misses is that it's the same rise. It's also 4,000, whatever it is. And this is what our human brains aren't trained to see. This is what monitoring and observability are for. This is what alerting is all about. Not just the rise, but the rise in conjunction with the other stuff I was talking about. And it comes only when we consider time frame to be a fundamental aspect of our triggers. Another pitfall is using fixed thresholds. There is no one threshold fits all. There's not even a one threshold fits most. Every system, it has its own unique behavior. When I say system, I don't mean just a server or just a router or just, it could be an application. It could be an entire set of microservices. It could be whatever it is. It's a system that fits together, and every system has its own unique behavior. So a better way to look at it is a baseline, right? First of all, use the monitoring tool to collect all that data and figure out what normal looks like for that system. And then you set your trigger to be 10% above normal or 1 sigma away or whatever you want to set it to, but you set it above. But you still have a problem. First of all, you see those little short stubby ones? Those might never trigger. I might never care about that. Okay, even though it's 10% over or whatever it is, it's still not a problem because it's still not high enough. Meanwhile, if I have a system like, let's just take a 1 gigabyte hard drive that's hovering at 70%, which is 700 meg. Okay, 10% takes me to 770 megabytes, which isn't like get out of bed urgent unless it's going fast, in which case that might not give me enough room. So the best way to do it is to have a baseline with a percentage threshold or whatever it is, and also have limits top and bottom. If it's not above this, I don't want to hear about it. If it's over this, I want to hear about it anyway. That kind of thing. Okay. Fixed thresholds, bad. Here, that's a better way to deal with it. Another trap is having a lack of automation. So with a disk full, 90% of the time, everyone knows what they're going to do. They're going to clear the temp directory, right? They're just going to clear out the temp files. And that actually works most of the time. The problem doesn't come back for a long time or whatever it is. And if that's the case, why not have automation do it? Why wake someone up or make someone stop what they're doing just to do that? As proof, I implemented this at a company and I cut the tickets down by 3,000 tickets a month, which had an overall result of a reduction of $8,000 in staff time. It really does make a difference. And the only reason I was able to do that was because I had automation that would just automatically go in, clear the temp directory, and if the problem went away, then it marked the ticket as resolved. One of the most powerful aspects about alerts is that they are witness to the exact moment when a problem happens. Nothing can be more effective than the right response at exactly the right moment. Now, some folks will skip over or avoid automation because they think it's hard, but the truth is that figuring out how to make automation work is as easy as asking one question to the person who's been getting that ticket. When this happens, what do you do? And they may tell, oh yeah, I just jump on, I type this command and off we go. Okay. Well, if that's the case, why don't I do that for you? It's an easy way to do it. So I want you to consider another relatively simple example. I've got an application running on IIS and it's slow. So for anybody who's watching this, who's ever managed an IIS server, you know that whenever anything happens, you do one thing and you do it immediately. You clear the application pool. So why not have automation clear the application pool and wait 5 minutes, 3 minutes, I don't care how long. And if the problem persists, then you do the same thing everyone does. You reset the IIS service, okay, and wait. And if the problem is persisting, then you rebuild the image or you restart the VM or whatever it is, fine. And then you wait. And then you vMotion it to another host or you move to a new location or whatever it is if you're cloud-based, that kind of thing. And then you wait. And then if all those things have not fixed the problem, then you send a ticket. But the really cool part about this is that, first of all, the human who gets the ticket knows that all those things have already been tried. They don't have to go through those steps. It's been done. They can now get involved with their big human brain when the thing that we need is their big human brain to think about what else might be the problem. But the other thing, if you're really on top of it, is that after each of those actions, you collect the results, the output of those commands or the output of that action, and you include that in the ticket so that they can see that, oh yeah, I cleared the application pool and there was an error message, or I rebuilt from image and it just went belly up again, or whatever it is, right? You can do that. And that takes me to the most important part of this talk, talking to people. Nicely, mind you. Nobody at your company is a psychopathic, homicidal clown. Probably. But with the same determination of the world's greatest detective on the trail of the real killer of my app 123. The only way to understand how critical an application or an issue is, the only way to understand how much anyone cares about performance is to talk to them and get that context, which is why you need to hunt for the great white useful alert. Now I say hunt because the person who initially asks for an alert is usually not the person you need to talk to. The person who asks for an alert is the requester. Requesters are the people who are charged with getting an application up and running and rolling it to production. And I have news for you, my friend. They lie. They lie all the time because you represent a checkbox that they have to have marked off before they can get their stuff into production and move on to the next thing. So they will tell you anything it takes just to get you out of their way. Oh, no weird problems here. We don't need anything except basics. This baby's coated like a steel rock made of angel farts and unicorn spit. They'll tell you anything. No, you need to find the recipient of the alert. You need to find out who is getting the alert and talk to them about their lived experiences and the things that they are concerned about or the things that they've already been seeing. All right. And I have some questions that I ask that person that help me zero in on an alert that is useful. The first question is, how do you know when something went wrong? Yes, I know the users called me. Okay. After that, though, you jump on the system, you type this command, you verify what the problem is. You know what that is? That's your alert trigger right there. That's how they know it's wrong. That's how you're going to know it's wrong, except you'll be able to know it long before they knew it. Second question, how do you know it's all better? A lot of people miss this question because in a lot of cases, all better is, hey, the problem's not happening anymore. But in a lot of cases, it's not that. I'll take a simple example again, a disk drive. So we know that bad is when it's above 90%. So are we saying that better is at 89%? Of course not. That's ridiculous. So, all right, 82%, 85%. Usually for systems like that, all better is when it's at, let's say, 70% for 20 minutes or a half an hour. We know it's stabilized. But you want to make sure that you know that, because most robust modern monitoring and observability systems have a reset trigger, which will then go back to your ticket system and not close, but mark the ticket as reversed or resolved. The reason why I say not closed is the only thing that should be able to close a ticket is a human. Only a human. You can mark a ticket as resolved or reversed, meaning it's not a problem right now and you don't have to get out of bed, but it does still have to be reviewed by a human so that you know how many times that thing happened if you're sawtoothing. Another question. Is there a knowledge base article for this? Yet. Because if there isn't, there needs to be. I refuse to roll an alert into production if there isn't a knowledge article, because people change jobs and everyone isn't available all the time. And you need to give people who are getting the alert, who are receiving it, some way of knowing what to do next if that problem persists. And I'm sorry, but if the knowledge base article says go call Bob, you better hope Bob doesn't win the lottery and goes and buys an island someplace. But in any case, knowledge base. And the last question, can you make this happen on purpose? It's amazing to me how many people ask for alerts because they assume or they believe that something will happen, but they've never actually seen it occur. Making something happen, of course, in tests, not in production, but making an error occur validates all the assumptions about your trigger, about the reversal, about all of it. So make it happen. So let's summarize. We have identified and interviewed the recipient of the alert for all the good context. We have designed an alert that matters because it has real world trigger elements. It takes duration and baseline into account. It includes automation. And finally, we've verified that the alert is built with the intent of immediate human action. Wonderful. What's left? The last lesson is the shortest to explain and the hardest to do. The work isn't over. What I mean by that is that alerts are not set it and forget it and they're good forever, right? Things change. People's experiences change. Applications change. You need to go back regularly, whether it's once a quarter, once every half year, once a year, whatever it is. Go back to those recipients and ask them, is this alert still doing what you want it to do? Have your circumstances changed? Has the usage of the application changed? Is there anything that we've learned about the system that would cause us to need a different kind of alert or even more alerts? Now, before you think that what you're asking for is being punished for your initial success or your good deed, remember that this is evidence of the fact that alerts are in fact effective, that they do not suck, because ultimately the alert is doing its job. Its job is to remove interruptions and toil from our workflow. Now, at this point, if you are feeling irritated, I did warn you that could happen, but now it's time to start mulling over that grain of an idea and creating a pearl of your very own. Thank you very much for taking time. I am ready for your questions. You can find me at Leon Adato on almost all social media platforms or leon@kentik.com. I look forward to hearing from you. Thank you very much.